Do you want to find an interesting tech discussion chat or a teammate to play with? Join the Hardware Lab Discord server using the link in the description. Linux gaming has taken a significant step forward in the past few years due to several reasons we are gonna talk about today. We will examine the current state of Linux gaming from a perspective of people who grew up gaming under Windows. We are all familiar with the Windows interface, we know about all its issues and advantages. However, Linux software, the terminal, and the Linux ways of interaction are foreign to us. This video will contain a massive amount of performance testing, but before that, I should explain how gaming on Linux is supposed to work. Hello and welcome back to Hardware Lab. The first step if you decide to switch to Linux will be which distro and interface to use. It sounds simple, decide which one you like and fix the issues that arise, right? Nothing can be simple when talking about Linux. Firstly, let's take a look at the available distros. Some distros are based on existing distros, forming a huge tree with a few roots at the top. The two most popular parental distros are Debian and Red Hat. Both of them have lots of different derivatives, and one of the most popular distros, Ubuntu, is a derivative of Debian. Distros based on Red Hat are also well known. This guy, Fedora for example, has a rapidly growing user base, and it's both technically advanced and pretty stable. However, these derivative distros have their own derivatives, such as Linux Mint, a very well-known Ubuntu derivative, or Elementary OS, a Mac-themed distro also based on Ubuntu, and it is one of the most beautiful Linux distros with their own custom desktop environment, and hordes of various niche obscure distros like Hawaii OS, which hasn't received an update since 2016. Another great tree of distributions is the one based on Arch Linux, the most hardcore and user-unfriendly OS that gives you the ability to manipulate your PC extremely deeply, which has no graphical installation and pre-installed desktop environment. This is a complete opposite of Ubuntu, or if you prefer macOS or Windows. It requires some skills and probably means that you will work with the system itself instead of working with applications to do something useful. You know, some of the Arch Linux community are really crazy since they are against all corporate software, including the open source, and take it too seriously. But in the Arch Linux tree there is something you might be interested in as well, Manjaro Linux. Probably one of the most popular gaming distributions with many benchmarks of Windows games that you can find on YouTube running perfectly fine. It is a lot more stable than vanilla Arch Linux, and that makes it more usable. And there are many other distros and other distros based on them. Does it still seem like a simple choice? I mean, just look at the full distribution map from Wikipedia. It's insanely huge. Many of these distros are made for specific purposes, like music distros or specific gaming distros, and honestly they are crap. Even Android and Chrome OS are technically Linux distros. But if we are to talk about something useful on a regular PC for gaming and content creation, these distros are generally divided into three categories. There are rolling releases, like Arch Linux, and stable distros like Debian. Rolling release distros are getting update for all the packages and drivers as soon as possible, and they stay up to date. However, this takes a hit on stability of those systems, meaning you could easily just break something with these updates. Stable systems don't have those problems, but often lag behind. Of course, some of the distros are trying to maintain balance, like Fedora. Fedora's standard install, with a fancy GNOME DE called Fedora Workstation, is our choice for this benchmark. Honestly, our experience with this system wasn't that great, and there was a lot of broken stuff we needed to fix manually via the terminal. Software support for Fedora is not too great as well, but probably it is still one of the best distros you can use in your everyday system. I mean, I can't give a recommendation here. Maybe your experience with something Ubuntu based or even Arch based like Manjaro would be better, But we tested Pop! OS, Garuda, Manjaro, Cutefish, and they were even more broken out of the box than Fedora. And even the same GNOME workspace in Pop! OS lacks of some nice features that are present in our system. However, Pop! OS is great for NVIDIA support, which is difficult to get working on the other distros, so if you have an NVIDIA GPU, we recommend checking this out. But if you still think that distro choice is the hardest step and after that everything works just fine, you are completely wrong. Choosing a distro is just the start of your Linux journey. It will just form the shape of the problems you will come across and have to fix manually. The issues are completely different in different OS, since they support different sets of software, they have different libraries out of the box, but the issues and limitations of a specific distro are present no matter of your choice. And this is the place to stop speaking about abstract terms and focus specifically on gaming and how games work on Linux. Windows supports a lot of graphics APIs, and especially different versions of DirectX, which is the most common graphics API used in games. While Linux doesn't support DirectX, since DirectX is a proprietary Microsoft technology. However, Windows supports the open standard APIs as well, like Vulkan. If there is a game running on Windows PC with Vulkan API, the exe file of the game just runs as it is natively supported and chooses the right API from the variety of available. However, running the same game on Linux is a much more complex task. Even when Linux supports the Vulkan, it has nothing to do with the exe format. There is no native support for Windows operating system APIs. This is where we use special software to provide these Windows APIs to the game, like Proton. Proton itself is a version of Wine, which is a software used to run Windows software on Linux, which was patched by Valve for better gaming compatibility. Proton has different versions that are suitable for different kinds of games. Proton GE is a version that is developed separately from Valve and is supposedly better. For this Vulkan game, Proton is enough to run it, but what if we have a DirectX game? In Windows, it works just fine via using the native DirectX implementation, but on Linux, we need one more compatibility layer to run this kind of game, either VKD3D or DXVK, depending on the DirectX version. VKD3D and DXVK are both used to translate the DirectX calls to Vulkan that is supported on Linux. The difference is that VKD3D works with DirectX 12 titles and DXVK with DirectX 11 and lower, like DirectX 9 for example. Since Vulkan is a much more advanced and low-level API than all these DirectX versions, it can fix some Windows games problems, especially with the old DirectX 9 and 11. But since none of those compatibility layers are perfect, it can cause some new issues as well. We will take a look at that later in the benchmark section of the video. What I want to mention here as well is that VKD3D is really an advanced tool that supports most of the newest features like ray tracing and variable rate shading. With Proton, VKD3D and some launchers for all that stuff, our DirectX game is finally ready to run on Linux. Wait, didn't I miss the launchers? Yeah, there are a lot of them. Each works with some games but doesn't support the others. The most popular is Steam Play, which is integrated with the original Steam client for Linux and works with Steam games. It works well, but the configuration can be a bit tricky. I mean, we tried to set up ray tracing support in Steam Play with a variety of launching commands, following various guides, but nothing worked. Some games like Director's Cut of Death Stranding didn't launch at all, but all of them looked like they just worked in some YouTube videos. What's the difference between our system and their? No one can answer. Driver version, distro, kernel version, Proton version or something else, we just don't know. Port Proton is an auto launcher, and it's almost perfect, but it has some issues as well. And the biggest problem is that it can't launch most games through Steam, but for that we have Steam Play. While Port Proton is really useful to run Uplay, Epic Games or even the pirated games, as you can run any exe file with it. But there is no guarantee it will work well. But if something doesn't run in Port Proton, there are some alternatives. There is the Heroic Launcher, which supports only the Epic Games Store and GOG, and Lutris, which supports EGS as well, and Uplay, Origin, GOG, and Steam. So with all these tools to try, we can be pretty sure that something like 80 to 90% of the games will probably work, and the question is just what will be the performance drop. Or is there maybe a performance gain? We will find that out in the benchmark section. But just to be clear how much stuff we tried and it just didn't run, here is the shorted list. We tried to run ray tracing in Dirt 5, Godfall, Mortal Shell, Deathloop, Chernobyl, Metro Exodus Enhanced, nothing of them worked. We even tried to simply run some games like Red Dead Redemption 2, Dirt Rally 2.0 and Halo Infinite, they do not work at all. And it's just funny how easily some of that stuff works on other people's PCs. You can easily find Metro Exodus running with ray tracing and Red Dead Redemption 2 tests through YouTube search, so probably some of that will run just fine on your build. Some of the games run correctly 1 out of 3 times, like Bioshock 1 and so on. Well, there is a compatibility checking tool for game support called ProtonDB, but you can't trust it 100% since some of the issues happen randomly on different builds. However, it's not as bad as it sounds, since most of the games that we tried work fine and the majority work just by simply clicking download and play. So the conclusion is that Linux is not very user-friendly, especially for gamers, no matter the distro you choose. But most of the stuff works completely fine and it's insane. Maybe like 2 years ago it sounded like a joke, but now it's fully useful as a gaming and walking system. For one game that doesn't run, there are tens of hundreds of games that will run completely fine, and the development speed of Linux systems is crazily fast. But what about other software? Can all those tools be used to run, for example, creativity software? Technically, yes, but with a lot of compromises. Since all of the mentioned compatibility tools are made especially for gaming, in some software you can forget about GPU acceleration, and those who know how bad it gets. Some software won't run at all, but maybe there is a lot of multi-platform software that is ported to Linux, or some fancy alternatives, probably open source, both yes and no. Since Linux is not very popular, there is a lack of financial incentive for developers to support it. And open source, well, you can't believe in open source and people's altruistic cooperation as a part of your communistic religion, but in fact it's just worse. For example, on Windows and Mac, you have a plenty of choices to edit your videos, as I'm now editing it in Apple's Final Cut. If you don't like Final Cut, you can use Adobe Premiere, DaVinci Resolve, Sony Vegas or whatever else you can choose, even Movavi if you're a beginner in that stuff. What about Linux? It has 2 options for serious video editing, Kdenlive and DaVinci Resolve with reduced functionality. It doesn't even support the H.264 imports, so it's quite painful to use. Before Kdenlive was made usable, Linux users were even using Blender to do the video editing. They really think it is suitable for that, I'm not joking. Kdenlive is a great open source tool, and it's definitely an achievement for open source developers. But it is just worse than what big companies offer with their software. Don't get me wrong, I like the open source philosophy, but the best open source products are the products from big developers that are created through their investments, like for example graphics technologies from AMD or Valve's Proton, which we are talking about today. And the same thing is true for a lot of use cases. For example, photo editing. Photoshop is not available for Linux, as well as Luminar Neo and Topaz. Music creation, there is no version of FL Studio. Even the performance statistics collection and screen recording is still the issue. Counting the 1% minimum and the average FPS just doesn't work correctly in some games. In other games, especially native ports, Mangahoot, which is the Linux alternative for Riva Turner statistics, doesn't work at all. Hello Heroic Launcher. To record the screen without a performance drop, we came to a very complex solution. Linux has a GPU encoding system called FFmpeg VAPI, which is supposed to use GPU acceleration, same as what HEVC does on Windows. But as I mentioned before, nothing can be simple when talking about Linux. FFmpeg API either skips frames or ruins the performance depending on the screen capture method when we are GPU bounded. So the solution that we came to, recording the GPU limited scenes on the CPU using X264 and CPU limited scenes with FFmpeg API. So we are sorry about awful recording quality and unreasonable hardware load statistics. This is just the current state of screen recording on Linux. But coming back to gaming itself, let's find out what performance you should expect while moving to Linux. Our system for the test will be a Ryzen 5 3600 6-core CPU, overclocked to 4.3 GHz, and 16GB 3600 MHz RAM with CL16, with a Radeon RX 6700 XT from PowerColor. We expected to see a high performance improvement in Stalker, since the game can properly use only one CPU core and runs under DX9, but the average boost is in fact meaningless. Bioshock was running under DX10 instead of 9, but it's really not a big deal here, and we decided to include it in the DX9 section. It shows some significant CPU performance improvement and a much better cores usage on Linux under DXVK. However, it is strongly related to the scene content. In this game, CPU usage is better on the Linux side, however the performance is worse. Probably the stuttering issue on Linux is related to shader compilation, which would explain why CPU is doing more work under Linux when achieving worse performance results. Anyway, stutters are present on Windows as well, so maybe the 90 to 100 FPS log could help to improve the performance stability for both. Moreover, we were not able to measure the performance statistics in this game on Linux system, as well as in some other games. Oblivion shows some significant performance improvement by moving to Linux and DXVK. Stutters are less noticeable and the FPS is higher. GTA 4 is another example of a completely broken DX9 title that doesn't run well on modern systems and pushes the DX9 to its limits. In this case, Linux and DXVK fully fixes all the issues. Gameplay on Linux is smooth and the FPS is as high as you would expect from this old game, with extremely high options in the settings menu. DX11 should be a superior API than DX9, and Tomb Raider 2013 is not a broken game at all. But despite that, Linux with DXVK shows a much better CPU performance in this title. Saints Row 4 didn't work fine even on the top tier systems back in the days, and it doesn't work fine on modern systems today. Running this game under Linux with DXVK can improve the overall performance significantly and, what's more important, get rid of stuttering issue. Average performance in this game is equal between both systems. However, 1% minimum FPS demonstrates that frame rate under DXVK and Linux is a lot worse. This is a clear win for Windows. Another Ubisoft's hardware-demanding title from 2014 shows a massive disadvantage on the Linux side, dropping mid-range CPU from 2019 below 60 FPS. At first glance, Watch Dogs 2 works better on Linux system, since this game is strongly limited by DX11 pipeline on Windows. but the high frame rate on Linux is very unstable, making the game unplayable with the advanced LOD setting pushed to its maximum value. Being a well-optimized game, Dirt 4 is running just fine on Windows with DX11, but Linux can improve the performance even further. This is a clear win for Linux, but the higher delta between 1% and the average values on Linux is not a good sign. Another game from Ubisoft that is strongly limited by the DX11 API on Windows. Highly detailed geometry in Assassin's Creed Odyssey requires a lot of CPU calculations that can't be managed properly by DX11 API. As a result of that, awful performance on modern machines that can't be properly utilized. DXVK on Linux fixed that completely and shows a performance that you would expect from a 12-thread mid-range CPU from 2019, overperforming the original DX11 game by more than 50%. Definitive Edition of Mafia Tool shows a bit better average performance on Linux, but the delta between average and 1% low is so high that it makes Windows a clear winner. The performance is just a lot more stable with DX11 on Windows. First test with VKD3D and DX12 title shows a performance hit on Linux to either meaningless or really meaningful amount depending on the scene. But 1% minimum FPS over 60 on Windows feels a lot smoother than 1% below 60 on Linux. There is no way of running Shadow of the Tomb Raider under VKD 3D on Linux. The game just doesn't run through Port Proton and Epic Games Store, so we were only able to run it with Heroic Launcher and DXVK. Since the game runs a lot better with DX12 on Windows and DXVK can use only the DX11 source, the performance in this game on Linux is a lot worse. Assassin's Creed Valhalla runs a lot better than Odyssey, even with more complex geometry and better graphics overall, thanks to perfect DX12 implementation. But Linux with VKD3D is still doing a good job here, achieving lower average FPS but slightly better 1% minimum, which theoretically means the framerate is more stable. Cyberpunk on the other hand shows a massive 1% minimum FPS performance disadvantage on Linux. The game is just not running smoothly enough. Far Cry is the game with really bad multithreading and CPU usage in general, even though it runs DirectX 12. But surprisingly, Linux doesn't have any advantage here. The average FPS is a bit higher on Linux, but the 1% minimum is a bit lower. Since Vulkan is natively supported by Linux and we can get rid of one of the emulation layers, it is not surprising that Linux runs the Vulkan game better in most scenes. The advantage is not too big, but it's a free few frames that are achieved only by switching the OS. Strange Brigade results are really unexpected. Unlike Rage 2, this game drops some frames by switching to Linux. World War Z also seems to run slightly worse on Linux system despite using Vulkan as the main API on Windows. Somehow even the CPU usage was slightly worse than on Windows. According to all the CPU-bounded tests, there is no clear winner between Linux and Windows in terms of gaming performance. But I think this is actually a great result for Linux. The fact that Linux gaming is not just possible, but comparable and even preferable in some scenarios is amazing. But until now, we didn't touch one more massive thing to discuss: Linux natively ported games. In fact, there are only a few of them. Sometimes games even have a Mac ported version, but don't have a Linux one, and that's a bit of a shame. Moreover, Linux natively ports are actually not completely native. Most of them are running through a special compatibility layer as well, Feral 3D. Feral 3D is something that replaces the XVK or VKD 3D and requires a manual implementation, so in theory it should work better. Furthermore, by running native games through Feral 3D, we use the native Linux apps with native Linux non-graphical APIs, so we are getting rid of the Proton compatibility layer, which takes some CPU time. So let's check out the performance of Linux natively ported games. Native version of Dot 4 in fact doesn't run any better than Windows game running under the XVK. There could be a small performance gain on average from using a native version, but the 1% minimum is even a bit slower. But it is still a better experience than playing this game under Windows. Native port of this game makes a huge difference, since now it is running better on average under Linux than under Windows. However, the frame rate even in native Linux port is less stable. Space Program is a very strange and hardware-demanding piece of code which performs a bit better on Linux using native OpenGL API instead of Feral 3D. Especially, I prefer the drop to 14 FPS instead of drop to 3 on Windows. Rise of the Tomb Raider native version is a complete shame. The average performance here is a lot higher than what we saw in the Proton and VKD 3D, but the stutters and framerate drops appear both in benchmark and gameplay, makes the game unplayable, but just in specific areas and locations. This is a very hard task to make any conclusion about this behavior, but going with Windows and native DirectX 12 is of course the best way to play this game. In CPU-limited scenarios in general, Linux is doing great, and we were expecting less from the platform that wasn't designed for gaming purposes. Of course, it's not perfect, and you should be ready to have performance disadvantage in many cases, especially when talking about frame time stability. But on the other hand, the most broken games that are limited by their original API from either DX9 or DX11 era are likely to be fixed by DXVK. Probably, when DX12 will become a limiting factor of modern games, VKD3D would also help to fix them, since Vulkan itself can manage your hardware usage a lot more efficiently. But GPU utilization is a more complex task, and in most cases more important, since you will be more likely GPU limited than CPU limited most of the time during game sessions. As an additional test, after checking the typical rasterization game's performance, we will also take a look at the ray tracing behavior. This particular aspect is one of the main advantages of the current gen games, and different implementations of that particular feature is in widespread use. So ignoring ray tracing performance in this test would be a wrong thing. But ray tracing uses a particular DXR library, which became a part of DX12 only 2 years after release. Moreover, it uses a special hardware ray tracing accelerators in a GPU, which sounds like a complex task for VKD3D. So let's check out how all these tools utilize the GPU and what performance to expect. This game previously showed a significant boost on Linux in CPU test. However, there is no significant GPU performance boost, and the 1% minimum is even a bit slower. Despite using the same DX11 API, Watch Dogs showed a massive GPU performance improvement, while CPU performance was almost the same in this game. However, stutters that are connected towards CPU utilization on Linux are still present, and it gives us a lower 1% statistics. There is only the DX11 version of Quantum Break that is present in our test, since activating DX12 in this game requires buying it in the Microsoft Store. And of course there is no Microsoft Store on Linux, but for Steam DX11 version, GPU performance on Linux is a lot better. Watch Dogs 2, unlike the first part of the series, shows equal GPU performance between both systems. The average performance result in Dot 4 is equal between both systems, but FPS on Linux is a lot less stable and more demanding to game scene. In terms of GPU utilization, Assassin's Creed Odyssey is still a broken game, but unlike CPU usage problems, the XVK can't fix it and the GPU performance is equal. Lower 1% minimum on Windows side is probably related to the CPU usage. This game is very unoptimized on Windows with the original DX11, and the XVK on Linux can't do nothing with this. GPU performance is equal, and we can see only the performance boost in some CPU limited scenes. At first glance, Rise of the Tomb Raider follows the same trend and shows equal performance, but stutters and FPS drops, even in strongly GPU limited scenes on Linux system, are very annoying. Probably 60 FPS lag could help here? In DMC, Radeon Relive missed some frames while recording, but of course the original gameplay was smooth. Depending on the game scene, one or the other system can perform better, but on average frame rate is the same. However, more important 1% minimum statistics is better on Windows. Latest Assassin's Creed title performs unexpectedly worse on Linux, and I have no explanation why it differs so much from the other games with DirectX 12 and VKD 3D. One more game with the same average GPU performance, but a lot less stable framerate graph on Linux. It should be mentioned that GPU load drops happens only with the X264 recording, so they do not affect on the final statistics. That was measured separately. Radeon Relive has missed some frames in this game as well as in DMC, but that didn't affect gameplay itself, so don't pay attention to that. Performance in Far Cry was pretty identical as well as in some other games, while 1% low was just a bit worse on Linux. As well as in Far Cry, FPS in Strange Brigade was pretty identical, but with a slightly slower 1% minimum of Linux. This is definitely not what we were expecting from a Vulkan game. It is also worth mentioning that Radeon Relive took some extra frames from Windows on recording, and of course it doesn't affect the final statistics. We are not pretty sure that we are CPU limited or GPU limited in this game on Windows, since power consumption is high, but the clocks are lower than on Linux and GPU load statistics reports drop to middle 80s. However, the performance advantage on Linux side is good enough, but we can't be 100% sure that it is not the consequence of Windows' worse CPU performance. One more Vulkan game that shows significantly worse results on Linux in terms of GPU performance. Again, I have no explanation of that, but according to our test, GPU usage in general is better through DXVK or VKD3D than through native Vulkan API, which doesn't really make any sense. Native version of .4 runs even a bit worse than the non-native DXVK.4 in terms of GPU performance, and it is still worse than the Windows version under DirectX 11. GPU performance in the native Rise of the Tomb Raider port is just a slightly above performance with VKD 3D, but the price of that? Awful CPU related stuttering that we saw before. AMD's ray tracing tech demo shows that ray tracing on Windows with native DXR runs at least 3 times faster. Pretty bad start for ray tracing on Linux. Far Cry shows a great Linux performance with ray tracing at first glance, but in fact, we are just strongly CPU limited on Windows. I would say Windows should be at least 2 times faster in this game with RT if we are GPU limited. In Control, CPU limitation is not the factor anymore, and we can clearly compare the performance with ray tracing, and results here are almost as bad as they were in a tech demo for Linux. Cyberpunk just proves what other games showed already. The performance is awful, even despite the fact that we turned on only ray tracing shadows and left reflections and GI disabled. In conclusion, I would like to state that gaming on Linux is not only possible, but it even has some advantages compared to Windows. However, I wouldn't recommend trying Linux as a gaming platform for the average user. There is still a lot of stuff to be fixed: ray tracing support, anti-cheating compatibility, and overall installing process. However, the progress that Linux has made for the past few years is insane, and it can be used as a gaming platform for people who want a stable system with fancy user interface and a lot of options for customization and controlling their PC in general. They won't lose too much from a gaming experience perspective. And that's it for me for now. Please join our Discord server using the link in the description. And as usual, stay up to date with AHL.